I wanted to share how I make my open source PCIe fan controllers, because who doesn't enjoy watching someone else's tedious assembly process? I designed the circuit boards in a panel of 4. This makes them easier to manufacture, but means I have to separate them out before assembly. The panel has grooves cut between the boards to allow them to be easily snapped apart, like a block of delicious fiberglass chocolate. Separating the boards leaves a rough edge, so I smooth them out with a scraper. I've tried several other techniques, but I find I get much better results doing it by hand. Let me know if you got suggestions for other ways I could do this. The whole point of the fan controller is to provide airflow, so I really wanted to use a bracket with ventilation holes. I looked everywhere, but I couldn't find a bracket I liked, so I did what any sane person would do and designed my own. I was torn between a powder-coated and nickel-plated surface finish, so I ordered samples of both types to test them out. Unfortunately, both options looked amazing and I still couldn't decide which one I wanted. In true indecisive fashion, I leave the tough decision up to the customer and just sell both options. The brackets arrive individually wrapped to avoid damage in shipping. I use a 3D printed jig to keep the bracket and circuit board perfectly aligned while I screw them together. I use black screws for the powder-coated bracket and silver screws for the nickel-plated bracket. A small microcontroller is used to set the fan speed. The microcontroller arrives blank from the factory and needs firmware installed before it can do anything useful. To upload the firmware, I made a programming jig using a Raspberry Pi. When the board is pressed down, spring-loaded pins make contact with the programming header. At the same time, a switch is activated, which starts the programming sequence. An LED changes to yellow to indicate the programming has started. Once the firmware has been uploaded, it's verified to make sure it was written correctly. If this is successful, the LED changes to green. Otherwise, the LED changes to red. Once the card has been programmed, I press the button to set the fan speed to 25%. This lets me make sure that the speed gets saved when the power is removed. When I've programmed all the boards, I plug them into a powered PCIe slot and attach a testing device. I make sure they start at 25% speed and then cycle through all the speed settings to reach 100%. The testing device checks that all the signals and voltages are correct, and lights up green if the tests have passed, or red if there's any failures. The boxes come flat packed. They're quick to assemble and have the delightful side effect of covering absolutely everything with cardboard confetti. I wanted to get custom boxes printed, but I would have had to increase the price of the product, so I decided to use stickers instead. Before packing the boxes, I've got to put together the accessories bag. I usually throw in an extra zip tie and fan mount. It's a lot cheaper to send an extra one than to ship replacements if I mess up counting. After a final visual inspection, I can pack the boxes. For extra protection, I slip the cards in an anti-static bubble wrap bag before they're placed in the box. The accessories bag then goes on top. If a fan is ordered, I'll place it in the box before shipping, then seal the box with a clear sticker. If there's anything you'd like me to dive deeper into, let me know, and if you're looking for a PCIe fan, you'll find a link in the description below.